Welcome. In this video lesson, we are going to go ahead and work on writing equations for a line of best fit or for a trend line. We're actually going to look at some real world data. So let's go ahead and take a look here. Susan just started a new job, and she is using the money she earns to save for a car. The table below shows how much money she has saved after 8 weeks. So week 0, she has 550, meaning that's how much she started with. Week 1, 675, and so on. So the very first thing we want to do, so you're going to follow along and do this in your notes, is we want to go ahead and make a scatter plot of this data. We always want to make sure that we label our axes and we use an appropriate scale. So my x-axis is going to go ahead and be weeks. So I'm going to label weeks down here. And then my y-axis is going to be the money saved. So money saved. Now for my weeks, it looks like I go by 1, so I'm going to have my scale be 1s. So here's 1, 2, 3, 4, 5, 6, 7, and 8. And then let's see, how do I want to go with my y-axis? Well, I have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of them. And I need to go up to 1,500. So it might make sense if I make each of them 200, right? So this will be 200, 400, 600, 800, 1,000, 1,200, 1,400, 1,600, 1,800, and 2,000. Okay, so I have my scale. Now I'm going to go ahead and plot points. So I'm going to plot the point 0 and 550. So here's 0, and then I'm going to go up to about 550, and we'll say right about there. Okay, then I have 1 and 675. So 700 would be right in the middle, so I'm going to go just below that. 2 weeks is 700, so right about the middle there. 3 weeks is 850. 4 weeks is 1,000. 5 weeks, 1,250. 6 weeks, 1,350. 7 weeks, 1,425. And then 8 weeks, I'm at 1,500. Okay, so there is my data. And now what I'm going to do, now that I have my scatter plot, is you want to go ahead and draw a line of best fit, and we're going to write the equation for this line. So when you write or draw your line of best fit, you're trying to have as many points above the line as you do below the line, and how far apart they are from the line is important. And we want to make sure that it follows the trend of the data. If I were to draw a line like this, that's not a good line of best fit. Even though I have the same amount of points as I do above and below the line, it's not really following the trend of the data. So that would not be a good line of best fit. Oop, I deleted some points. Let me put those back up there real fast. 700, 1,425, and then 8 weeks would be 1,500. Okay, there's my points. So now I'm going to go ahead and draw my line of best fit. Now, not everyone's line is going to be the same, but we should be fairly close. I'm going to follow the trend of my data. And right there, it looks like a fairly good line of best fit. Okay, so I'm going to go ahead and leave that as my line. Now what we have to do is we have to write the equation for the line of best fit. So we have to remember how we write an equation between 2 points. That's what we're going to do, okay? In order to write our equation, you are going to pick 2 points on the line. Now they don't necessarily have to be the original data points. They just need to be some easy points that we can detect. So for example, I really like this point right here because it looks like it passes right through that corner piece. So that point right there is 4 and 1,000. And I also really like this one right here because that's at 7,1,400. Okay, so those are the two data points that I'm going to pick. Now remember, that 7 and 1400 was not necessarily a point that I originally plotted, but it is a point on my line. So when we write our equation for our line of best fit, we have our 2 points, and we are going to find the slope. And we take y2 minus y1 over x2 minus x1. So I'm going to take my second y value, which is 1400, and I'm going to subtract my first y value, which is 1000, divided by my second x value is 7, subtract 4. So 1400 minus 1000 is 400, and 7 minus 4 is 3. Now I want you to go ahead and give this to me as a decimal. So I want you to divide 400 divided by 3. And what I end up getting is 133.33, and we'll round to 2 decimal places. So that is my slope. Okay, so my slope is 133.33. Well, now I need to go ahead and find my y-intercept. We are going to write our equation in the form y equals mx plus b. I'm going to pick one of the points that I use to find my slope, and I'm going to pick that very first point. And I'm going to use those values in my equation. The y value for the point I picked was 1000 equals, well, my slope is 133.33. My x value in the point I picked was 4 plus b. So now I need to go ahead and find b. I'm going to take 133.33 and I'm going to multiply that by 4. And so I have 1000 equals 533.32 plus b. To get b by itself, I'm going to take 1000 and subtract 533.32. And when I do, I get b equals 466.68. Well, now I know my slope, and I know my b, which is my y-intercept. So I can go ahead and write the equation of my line, which is y equals 133.33x plus 466.68. So there we go. There's the equation for our line of best fit. Let's look at our graph. I said that the y-intercept was 466.68. If I look at my graph, does this y-intercept right here look about 466.68? I would say we're fairly close to that. We're in the ballpark. So that makes sense. You always want to check to make sure that your y-intercept actually makes sense to the line that you graphed. Okay, let's go ahead and answer the next question. What's the real-world meaning of the slope? We're going to write our slope as a fraction. And my slope is 133.33, and I'm going to write it over 1. That's just going to help me find the real-world meaning. Recall, slope is the rise over the run. So the rise is how much we go up. Well, if we look at our scale, we are going up in terms of money, and our run, we are going over in terms of weeks. So I'm going to put those units on my slope. This is going to be money, and this is going to be weeks. Well, let's think about what that means. What this is telling me is that Susan, okay, her name is Susan, is making $133.33 per week. That's what my slope is telling me. On average, she is making $133.33 per week. All right, now let's talk about the y-intercept. Well, my y-intercept was 466.68. Well, what does that number represent in terms of units? Since it's the y-intercept, it touches the y-intercept right here. So that 466.68 represents money. When? After how many weeks is what we have to explain. Well, she's going to make $466.68 after 0 weeks. So it's important that you include units and you tell me when that happens. So 0 weeks. Well, how much did she start with at 0 weeks? She started with 550, My equation says she started with 466. We're okay. Right? Remember, this is just a trend line. This is just how the data tends to flow. Well, now what we want to do is we want to use your line of best fit to predict how much money Susan will have saved over 20 weeks. Well, weeks is my x value. So I'm going to take my equation, which is y equals 133.33x plus 466.68. And everywhere I see an x, I'm going to plug in 20. So I end up with y equals 133.33 times 20 plus 466.68. So let's use our trend line, or our line of best fit, to help us predict how much money she's going to have. I'm going to take 133.33, multiply it by 20, and then add 466.68. And I end up with $3,133.28. So the great thing about these trend lines or these lines of best fit is that they help us predict. Okay, let's look at this one. If Susan needs $6,000 to purchase her car, when is she going to have this amount? Well, this money right here is my y value. So again, I'm going to take my equation of y equals 133.33x plus 466.68. And everywhere I see a y, I'm going to plug this number in. So 6,000 equals 133.33x plus 466.68. And I'm going to solve for x. So I'm going to subtract 466.68 from both sides. 6,000 minus 466.68 is 5,533.32 equals 133.33x. And now to get x alone, I'm going to divide by 133.33. So I'm going to take 5,533.32 divided by 133.33. And I end up with 41.54 for my x. Well, the question was, after how much time is she going to have enough money to buy this $6,000 car? Well, at 41 weeks, she's not going to be quite there. But in the middle of 41 weeks, she should have enough, right? So we're going to go ahead and round this up. We're going to say after 42 weeks, she can go ahead and purchase a car for $6,000. So that's what our line of best fit predicts. So there you go. That's how we can use some bivariate data. Our bivariate data was weeks and money. And we can use that data to write an equation for our line of best fit and make predictions. So there you go.